Oklahomans pay the hidden cost of fossil fuel extraction. Reported by Chastity Sade, the 24th of July, 2025. Oklahoma City-based News 9 reported on April 4th of this year that two earthquakes had struck near Enid, Oklahoma at 4 a.m. that morning, one measuring 2.8 and the other 2.9. Earthquakes were recorded last November, August, February, and January, with the one in February being one of the biggest quakes recorded in Oklahoma history. On February 2nd, 2022, families were jolted awake at 11:30 p.m. by what sounded and felt like a bomb going off. The town of Prague, Oklahoma was near the epicenter of a 5.1 earthquake that shook the entire state. The article reveals that this earthquake came after over a decade of increased seismic activity in a region that does not have any major fault lines or a history of major earthquakes. So why have there been so many earthquakes? The answer lies with the fossil fuel industry's injection of wastewater into the earth. To get a deeper understanding, let's trace the history of oil in Oklahoma. Oklahoma has been an oil, natural gas, and coal producer for well over 100 years. Prior to the arrival of Europeans, indigenous peoples made use of the oil springs that seep from the ground for medicinal purposes. In 1897, the first commercial oil well began operating in the state, and since then, over 500,000 oil wells have been dug in Oklahoma, making it the fifth largest oil producer in the U.S. The fossil fuels that lie in the ground in Oklahoma are due to the geological processes that have been happening for over hundreds of millions of years. Let's look at a few that are relevant to the oil industry. Deep under Oklahoma lies a basement rock made of igneous stone, and right above this layer is another layer of stone that was formed in the Cambrian period around 500 million years ago. At this time, this part of the earth was covered by seas that contained hard-shelled marine life. Their skeletal remains collected and compressed over time to create limestone and dolomite. This stone is quite porous and able to absorb water with ease, and is known as the Arbuckle Formation, and over time it has uplifted and subsided to create the Arbuckle Mountains in Oklahoma, as well as a very deep layer where wastewater can be deposited. Several layers above the Arbuckle Formation lies the Mississippian rock. Around 350 million years ago, during the Mississippian period, layers of limestone and shell, embedded with organic material, formed together. This is where much of the oil being extracted today lies. Around 300 million years ago, the Pennsylvanian period brought swampy conditions that created pockets of coal and oil in a layer of sandstone. This layer sits atop the Mississippian stone and was the target of the first well digging projects in Oklahoma. This map shows the various layers of stone found in Oklahoma and highlights the layers where oil can be found. Here you can see the igneous base layer made of granite and rhyolite, the limestone layers, and the petroleum-rich shell and sandstone layers that lie in between the limestone. This is a drawing of the Anadarko Basin, one of the most productive oil regions in Oklahoma. Over time, oil drilling has evolved. When oil drilling first began, the wells went down between a few hundred to a couple thousand feet. Once these wells were dry, new methods for extracting oil needed to be used. In the 1970s, deep well drilling was introduced, increasing depths to 30,000 feet. This allowed for untapped reserves to be extracted. In the early 2000s, drillers in Oklahoma began to use horizontal drilling that allowed for lateral tapping of formations. This allowed them to tap into the shallow shell formations that lay between the limestone, and they also began to employ techniques such as water flooding and hydraulic fracturing that allowed them to extract more oil and gas. Water flooding is a technique in which water is sent down into the wells to create an increase in pressure, driving the oil and gas out of its pockets. Hydraulic fracturing or fracking is similar, except that it also involves the use of a drill head that punctures the rock around it. The fracking liquid is pushed into these fractures, releasing more oil and gas from the rock layer. The implementation of horizontal drilling and fracking created a boom in the oil industry in Oklahoma. One of the byproducts of oil and gas extraction is very briny water. This water is called produced water and is pumped out of the ground along with the oil. This water is a combination of the water that's already in the ground and the water that's pumped into the well to aid in increasing pressure. The produced water contains chemicals that are used as additives to aid in extraction, and minerals and microorganisms contained in the rock layer. This includes a high level of salt and sometimes radioactive substances. For every barrel of oil that is extracted, up to 10 barrels of water is also produced. Now we come back to the reason for the earthquakes. Surprisingly, all this deep digging and injecting of water into the ground to get the oil and gas out doesn't cause much seismic activity. It's what is done with this toxic briny water that causes the shaking. One of the most cost-effective ways to safely get rid of this water is to put it back into the ground. However, instead of putting it back into the Pennsylvanian or Mississippian layers from which it came, much deeper wells are dug down into the Arbuckle layer. Here lies the absorbent limestone that readily takes on water. When a high level of water is injected into this layer too quickly, the increased pressure disturbs the underlying basement rock, and the faults in this basement layer begin to slip, causing the earthquakes. The earthquakes that have plagued Oklahoma in the last 15 years have cost an untold number of dollars in property damage. The problem became so bad that legislators decided to increase regulation of the oil and gas industry and to create a plan to reduce the number of earthquakes. These regulations have resulted in a marked decrease in seismic activity in the last 10 years, but the 5.1 quake from last year shows that there is still a threat. However, there is hope for the future. Recently, the Oklahoma state government approved an act that encourages oil companies to filter and reuse the water for various applications. Researchers are busy finding the most efficient ways to clean the water and are considering ways to extract useful metals and minerals from the water for use in agriculture or even batteries and electronics. It is difficult to get the water clean enough to be used as drinking water, but it may be useful for irrigating non-food crops or lawn watering. Human-induced seismic activity is not only affecting Oklahoma, it increases earthquakes in Arkansas, Texas, New Mexico, and beyond. Anywhere where there's an increase in wastewater injection, the shaking strengthens. In universities all over the country, researchers are in a rush to find ways to safely reuse this wastewater in the most efficient way possible.